Picture two engineers. Same degree. Same starting salary. 5 years from now, one of them is obsolete and the other is running a team. The difference isn't talent. It's not even hours of practice. It's a skill that barely had a name 3 years ago. And if you work anywhere near technology, money, or decision-making, this shift is already happening around you, whether you've noticed it or not. For 40 years, the path was simple. Learn to code. Learn it well. Get paid well. That formula built entire economies, entire university departments, entire immigration pipelines. But that formula was built on a single assumption, that writing code is the scarce, valuable skill. Foundation models, the large language models now embedded in everyday developer tools, are challenging that assumption directly. Reports on their technical capabilities show they can generate, debug, and integrate code at a level that changes what valuable even means in this profession. This isn't a hypothetical disruption. It's already inside the workflow of working engineers. To understand what's replacing raw coding ability, we need to look at what employers are actually tracking. The Bureau of Labor Statistics doesn't just count software developer jobs, it tracks the emergence of new, AI-adjacent job titles, along with the wage and growth trends attached to specific technical competencies. And separately, the Stack Overflow Developer Survey, one of the largest crowdsourced pictures of what developers actually do day to day, has been tracking a measurable shift. Developers are adopting AI tools at a rising rate, and that adoption shows up differently across experience levels and career stages. Put those two data sources together, and a pattern starts to emerge. The job title software developer hasn't disappeared, but what companies pay a premium for inside that title is changing. Here's the hidden pattern. The engineers pulling ahead aren't necessarily the ones who memorize the most syntax. They're the ones doing 3 things well: prompting, evaluating, and integrating. Prompting, crafting the input that gets a model to produce useful, precise output. Research on modern LLMs has found a direct correlation between how a prompt is constructed and the quality of what the model returns. Evaluating, judging whether that output is actually correct, safe, and fit for purpose. Anthropic's research on evaluating and aligning language model outputs treats this kind of critical evaluation as a distinct engineering discipline in its own right, not just a side task. And integrating, taking model output and weaving it into a working system, a business process, a product. None of these 3 skills require you to have memorized a compiler's error messages. All 3 require judgment. That's the pattern. The scarce skill migrated from can you write it to can you direct it, check it, and make it useful. This isn't a fringe theory. Analysis from outlets like Harvard Business Review and McKinsey on the future of technical skills in an AI-driven economy has documented companies actively retraining engineers, moving them off pure coding tasks and onto prompt engineering and model evaluation workflows. That same analysis lays out frameworks for distinguishing prompt engineering as its own skill gap, separate from traditional coding weaknesses. Meanwhile, the Stack Overflow data shows this isn't evenly distributed. Different generations and experience levels of developers are adopting these AI-native workflows at different speeds. That means a gap is opening. Not a gap between coders and non-coders. A gap between people who treat the model as a tool to direct and people still trying to outtype it. Here's the turning point in how we should think about this. It's tempting to frame this as AI replacing engineers. That's the wrong frame. What the evidence actually supports is narrower and more useful. Certain technical competencies are being commoditized, while others, the ones tied to judgment, direction, and evaluation, are becoming more valuable. Anthropic's research on evaluation frameworks makes the same point from a different angle. As models get more capable, the job of checking their work becomes more important, not less. In other words, the machine getting better at writing code doesn't eliminate the need for human. It relocates the human upstream to deciding what to ask for, and downstream to deciding what to trust. So what does the outcome look like on paper? The Bureau of Labor Statistics Occupational Outlook already tracks new, AI-adjacent titles emerging inside the broader software field, along with wage and growth data tied to specific competencies. The Stack Overflow survey shows adoption of AI-based workflows rising year over year. And the capabilities research on modern LLMs shows this isn't a temporary plateau. These systems are documented to perform real code generation, debugging, and integration work today. Taken together, the outcome isn't a prediction of collapse. It's a documented, ongoing redistribution of where value sits inside a technical career. The lesson here isn't learn to code or don't learn to code. It's that the definition of technical competence is being rewritten in real time, and the rewrite favors people who can direct a system, judge its output critically, and integrate that output into something that actually works. That's an interpretation, not a certainty. No source can tell you exactly how your specific job will change. But the pattern across capability research, labor data, corporate case studies, and developer surveys all points the same direction. Judgment is becoming the premium skill, not typing speed. So what can you actually do with this? If you're already technical, the practical move is to treat prompting, evaluation, and integration as skills worth deliberately practicing, not side effects of using a tool, but disciplines in their own right, the way Anthropic's research treats evaluation as a distinct engineering competency. If you're earlier in your career or adjacent to tech, the McKinsey and HBR style analysis suggests paying attention to which companies are actively retraining staff toward these workflows. That's a signal of where demand is heading. This is general, educational context, not personalized career or financial advice. Your specific situation deserves its own research and, if needed, a conversation with a professional who knows your circumstances. The engineers who win the next decade probably won't be the ones who type the fastest. They'll be the ones who learn to ask the right question, catch the wrong answer, and build something real out of both. If this changed how you think about your own skills, subscribe to The Hidden Lesson. We track these shifts before they become obvious, so you're not the last one to notice. And tell us in the comments, are you learning to code or learning to direct?